Okay, so we are DMA10, and we are going to start today with section 2. I know there's a section 1 on computer work, but that we will do actually at the end. It's mislabeled. It's actually the last section in DMA10. So we actually technically start with section 2. The beginning part of section 2 is that we need to learn some of the vocabulary. The keywords that you need to know when you are doing addition, you're going to see the word sum. And if you look in your workbook on page 1-3, I'm going to make notes, see chart. This has an all-inclusive list. I'm just going to put the keywords beside of it. But if you see sum, plus, increased by, more than, total, added to, that's when you're going to be adding. If you see a minus sign, one of the keywords that you will see will be the word difference, to find the difference of numbers. Or if something is less than another number, or if you see the word minus, subtracted from, fewer than, decreased by. So you'll see various keywords for multiplication, for subtraction. For multiplication, and usually when I write multiplication, you'll see me write it and it looks like an asterisk. The reason I do that is when we get to DMA 40, we're going to be using variables X, Y, Z. So out of habit, I will usually do an asterisk. Another thing you'll see for multiplication will be a single dot. That's about mid-height of the number. Those are typical ways that you'll see multiplication signs written. The key word here I want you to remember is the word product. If they say find the product of two numbers, that means you're going to multiply. If you see something like a number times another number, you're multiplying. A key word that you wouldn't think of is the word of. Like, what is 25% of 1,000? The word of would also mean that you're multiplying. If something is twice, double, triple, quadrupled, again, you'll be multiplying. For division, the key word for division, and this was on the exam we looked at when we were online a little while ago, the word quotient. The word quotient means that you're going to divide. If you see the word per, like if you're calculating miles per hour or how much you get paid per hour, per would also mean division. And then this symbol that you see here would be equals. Equals is equal to, you may see the word is or was, you may see the word yields. So this is some of the vocabulary that you'll need to be sure that you are making yourself familiar with. If you're in your workbook, if you turn in your Leap Blog workbook, you're going to see they give you a lot of different examples in here. But if you will, turn in your book to page 1-6. So if you go to page 1-6, we're going to look at these 4 problems that we have. A family bought a house for $185,700 and later sold the house for $201,200. How much money did they make by selling the house? So what operation are we going to need to do here? We are going to need to, if they've sold it, we're going to need to do a subtraction. So they sold it for $201,200. They originally bought it for $185,700. We're going to do a subtraction here. So this is the price they bought it at. This is the price they sold it at. And we're trying to calculate the amount of money made on selling the house. So what we're going to do is we're going to do a subtraction. Now, the first time I do this, I'm going to show you longhand how to do the subtraction, but realistically, you are able to use your calculator to do your subtraction. So here we start in the ones column. That would give us a 0. 0 from 0 is still 0. We can't subtract 7 from 2, so we're going to borrow. That 1 becomes a 0, and the 2 becomes a 12 because we're borrowing a 10. So 7 from 12 would leave us with 5. We can't subtract 5 from 0. So what we're going to do, we can't borrow from a 0, so we're borrowing actually from the 20. The 20 is going to become a 19, and that 0 we had here would become a 10. So 5 from 10 would leave us with 5. 8 from 9 leaves us with 1, and 1 from 1 is nothing. So we would have $15,500 made on the sale of the house. If you're using your calculator, you're going to type in your 201,200 minus your 185,700, and you'll see that you get 15,500. As I told you, you can use your calculator on your test. What you'll want to do anytime you do testing is that in doing your work is write down what you're doing on paper, just as I had here. You can have this written out. But if you're allowed to use your calculator, by all means, check your work and be sure that what you did matches the answer that you have there on paper. Okay, so let's look at question number 2. 2, we have Alvin and John go to the cafeteria on campus to eat dinner. Alvin orders a hamburger, onion rings, and a soda. John orders a hot dog, french fries, an apple, and a soda. Who orders the cheaper meal according to the chart below? And then it says by how much. So we have 2 people. We have Alvin and we have John. So we have 2 people. And I'm still on page 1-6. This is the second question. Alvin buys a burger. When I look at my chart, a hamburger is $4. He gets onion rings. Onion rings are $3. And he gets a soda. A soda is $1. So that's going to be Alvin's. John gets a hot dog. A hot dog is $2. He gets french fries, which are $2. He gets an apple, which is $1, and a soda, which is $1. So 4, 5, 6, 7, 8. Alvin's is $8. John's is 2, 4, 5, 6. His is $6. So when they ask who orders the cheaper meal, which of these is the cheaper amount? The cheaper meal would be the $6. So John is the one who orders the cheaper meal. And then it says by how much? That's where we're going to do 8 minus 6. And it's cheaper by a total of $2. Okay? Let's look at question 3. So go to your next page. It's still the same page, but at the top of that column, and we have a college student. A college student has $850 in her checking account. So in the checking account, we have $850 at the beginning. At the beginning of the semester, she spends $314. So she spends $314. We have an $850 checking account balance. We spend $314 to buy books and $40. So $314 is books, $40 for a parking permit. After receiving her paycheck, she deposits $550 in the same account. So she deposits $550. Now we want to know how much money is in the account. Okay, so let's figure out how to do this. If we have a balance of $850 and we spend $314 and $40, that means $314 and $40. If we add those together, combine those, that's going to be $354. So we're going to subtract $354 from, because this is how much she spends. So we have $850 minus $354. We have $496 in our account. She then got paid and deposited $550. So when you get paid and deposit money, you're adding that money too. So we're going to take this and add the $550. So what we now have is $1,046 because they're asking what is her account balance now. So you have to use the words of spending to know we're subtracting, and then deposits to know that we're adding that amount back. The next question we have is a whole pizza is 3,624 calories. If the pizza is cut into 12 equal pieces, how many calories will each piece have? Okay, equal pieces means we're going to do division. So we have 3,624 as our calories, and we're going to cut it into 12 pieces. So let's look at what long division is. Long division, we have the number 12, and it's going to go into the first two digits here. Okay, so 12 doesn't go into 3, but it goes into 36 3 times. 3 times 2 is 6. 3 times 1 is 3. When you do long division, now you subtract. 36 minus 36 is nothing. There's nothing left. We bring down the next value, which is a 2. Does 12 go into 2? No. 12 does not go into 2, so we put a 0 here. 0 times 12 is 0, so we still have just a 2. We bring down the next digit, which is 4. 12 goes into 24 2 times. 2 times 2 is 4. 2 times 1 is 2, and when we subtract, there is no remainder. So what we have would be 302 calories per slice of pizza. Okay? When you're working in your workbook, at the end of each section, you're going to see that there is a location, a little blue box at the end of the section where you'll see answers. Your workbook is self-checking, so once you do the work and you're writing in your workbook, you check it. If you missed it, then go back and redo it so that you can figure out how to go about getting that correct solution. Okay. The next part that we're looking at here is going to be section 3. So here in section 3, because today our goal is to do sections 2 and 3. Section 3, we're going to look at exponents, square roots, and order of operations. Okay, so let's take a moment and we'll start with exponents. When we deal with exponents, we have a value that we call a base, and a base is raised to a power. The power is the exponent. So if I have, let's say, 2 to the 4th power, what that means is not 2 times 4 is 8. That's not the meaning of it. It means we're going to multiply 2 times itself 4 times. 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. And 8 times 2 is 16. If you want to use your calculator to do this calculation, you would type in your base number 2 first. The only exponent on a key is a squared, and ours is not squared, it's to the 4th power. So look above the division key. Do you see this key here? I call it a caret. If you press that key, you see it raises it up, and then what I'm going to do is type in my exponent 4. So 2 to the 4th power, press enter, I get the 16. Okay? If I were to, let's say, I give you this. Let's say I give you Let's say I give you 5 times 5 times 5, and I want you to write this in exponential notation. My base number is 5, and how many 5s do I have? 1, 2, 3. So my exponent would be a 3. If I want to do that calculation, I can do 5 raised to the power of 3, and that's going to give me 125. You can feel free to use your calculator to do these, but I just want to be sure that you're aware of what it is that you're keying in. Okay? Now, that's taking something and raising it to a power. Now, the opposite of addition is subtraction, and the opposite of multiplication is division. So, if we multiply something, or in this case, we're raising it to a power, the way to undo that would be to find the square root of something. Now we're going to look at, in a later DMA, finding a cube root, fourth root, fifth root, all of these other roots, which we call radicals. What we're looking at here is squaring something and then taking the opposite of that, which is a square root. So if I were to have, let's say, 5 squared, that means 5 times 5 would be 25. But if I wrote down a 25 and had it under the radical sign, that would be finding the square root of it. The square root of 25 would be, in essence, if I factored it, I would have 2 5s. And in order to get your solution, the square root means 2. So I have 2 5s, and the square root of 25 would be the number 5. Let's look at this. What's the square root of 49? The square root of 49, if you multiply the like numbers, would be 7 times 7. So you have a pair of 7s, that solution would be 7. If I said, what's the square root of 16? What do you multiply times itself to get 16? A 4. What's the square root of 100? What do you multiply that's the same to get 100? 10 times 10. So the square root of 100 would be 10. If you go to your calculator to do a square root, you're first going to press the blue key that says second, and then look at the x squared above it. Do you see this little radical symbol? So if I do the blue key and then press that key, I get my square root sign. I can now type in my 25, and that would give us a whole number 5. Second square root, type in my 100, I get my solution 10. So when you're finding the square root of a number, if I want to do the square root of 400, that would be 20. You can key those in just there, just as you see them, okay? The next thing we're going to contemplate is going to be a number that is a very special number. This number is 0. The number 0 can be special in the sense of, if I add a number to 0, I get the same number. So if I say 4 plus 0, what is my answer? 4. My answer is the same number. If I subtract 0, let's say I have 8 minus 0, if I subtract nothing from it, I still have the same number, 0. The difference of any number and that same number is 0. So if I had a positive 7 and I subtracted a 7, the difference of those numbers would be 0. I can multiply any number times 0 and my answer will always be a 0. If I take a 0 and I divide by any number possible, it doesn't matter what number you key in, my answer is always going to be 0. However, if I have a number, and I'm going to write any number, if I have any number and I try to divide by 0, I'm going to get a special answer that's called undefined. I get undefined because I cannot divide by a 0. So let's look at that. Any number plus 0 gives me that number. Any number minus 0, I still have that same number. When I have a like, both positive and negative, they subtract out to be 0. Any number times 0 is 0, and 0 divided by any number that I might choose is going to give me a 0. However, if I take a number, let's say I take 87, and I want to divide that by 0, you cannot divide by 0. We get an error message about dividing by 0. We cannot do it, and that's where we get the undefined from, because we cannot divide a 0 by another number. The next part that we're looking at here is the order of operations. Okay? So for the order of operations, you've probably heard a lot of different acronyms to memorize. Please excuse my dear Aunt Sally. Um, so you can use any kind of acronym that you might want to come up with. I'm going to just jot down the PEMDAS. The way I like to write this out, and I like to do mine visually, the P represents a parenthesis. So if you have something that is written in a parenthesis, grouping symbols, you're going to do that first. Then if you happen to have any exponents, that's going to be next. Now, the multiplication division, it does not mean do all multiplying before dividing. It means multiply or divide working from the left to the right, whichever one you get to first. If a division is further left than the multiplication, that's what's done first, reading it left or right. Same thing with the last two. The addition or the subtraction are done in the order left to right. That's the order that you would do those in. So let's take a moment and let's give this a try. Okay. So if you will look in your workbook on page 1-13, I'm going to take one of these. Here we have 48 divided by 4 times 2. Notice the dot for the multiplication, minus, and then 7 minus 5. So what I want to do first in this scenario is the parenthesis. 5 minus 7 leaves me with, excuse me, I read it backwards. 7 minus 5 leaves me with a 2. Okay, so we did the parenthesis. Are there any exponents? No. Is there any multiplication or division? Well, yes, here and here. I have to do the leftmost one first. So 48 divided by 4 leaves me with 12. I'm going to finish recopying. I've got times 2 and then minus, and that became a 2. So I did the first one, the division, and now as I look left or right, I do have a multiplication. So 12 times 2 is 24. And then last we have 24 minus 2 leaves us with 22. Okay, let's try another one. This one has a numerator and a denominator. We have a square root of 4 plus 4 squared over 5 times 20 minus 16 minus 3 squared minus 5. So as we do this problem, what I recommend is we're going to simplify the top and the bottom. The square root of 4 is going to be a 2. And if I raise 4 to the second power, 4 times 4 is 16. And then we're going to add 2 plus 16, and that's going to give us 18. So our numerator is going to be an 18. In the denominator, we have a parenthesis. So 20 minus 16 is going to give us 4. So we have 5 times 4 minus, we have an exponent. 3 squared is going to give us 9. As we continue with order of operations, we're going to do multiplication first. So we have 20 minus 9 minus 5. Left or right, 20 minus 9 is 11. And 11 minus 5 gives us 6. Now that we have this, we can do 18 divided by 6 gives us a solution of 3. Now to check this using the calculator, this is what I would do. To check this, do the top and bottom numerator and denominator separately. So first I'm going to do second square root and type in my 4. Now I want you to notice something. I'm going to do something and it's going to be incorrect. If I press plus, do you see how the plus is still under the radical? Let me come back and delete that plus sign. To make the cursor come out from under, do you see the little blinking arrow? Press the right arrow key. Now it's out from under the radical and there's no line above. Now I can do plus 4 and that's going to be squared. So type in only the numerator, press enter, and that gives me my 18. To do the denominator, I have 5, a parenthesis, 20 minus 16, close my parenthesis, minus 3 squared minus 5. When you key all this in at one time on the calculator, it knows the order of operations, and that gives me a 6. That's what we had here, 18 over 6. That means 18 divided by 6 gives us a solution of 3. Okay? Now, one last thing that I'm going to show you here with this particular section is we're going to look at a formula that is called the Pythagorean theorem. Okay, so let's spell this big word. Pythagorean. Pythagorean theorem. This has to do with a 90-degree angle. So if you have, and this little square means a 90-degree angle, let me write down 90 degrees. It's true for a right triangle. We label the Pythagorean theorem. The two sides that make the 90 degrees are labeled as A and B. The diagonal is labeled as the C. The A and the B are also called the legs. The A and the B are called a leg. The diagonal, the C value, has a special name. It's called the hypotenuse. The formula that we have for the Pythagorean theorem is a squared plus b squared equals c squared. So if you're given two of the three dimensions, we can calculate that other missing dimension, okay? So you may need to refer back to this as I'm doing our problem. We're going to do a problem, two of them, on page 1-15. The first one, they give us a triangle, and it's a right triangle, and they ask us to label. It says the legs are 9 and 12. If this is my 90-degree angle, the legs would be the two that form the 90 degrees. We're trying to calculate this missing value, and actually we can just call that a C, and that's a 9, not a letter A, okay? So our formula is a squared plus b squared equals c squared. These two are my A and my B. So I have 9 squared plus 12 squared equals c squared. Now let's use our calculator to do the left side, okay? So we have 9 squared plus 12 squared. Enter. We get 225. So 225 is equal to c squared. We want an answer of c, not c squared. So to get the c alone, we have to take the square root of both sides. That then makes the c be all by itself. So if I do second square root and type in 225, I get a solution of 15. So the length of this side here is going to be 15. Okay, let me give you another one. And this is like a real application here. This one is a TV. It says the opening in my wall for a new TV is 27 by 36 inches. What is the largest TV I can put in that spot? Remember that when purchasing a television, the size represents the diagonal length of the screen. So if we label this picture below and pretend I have a perfectly drawn rectangle, 27 is our dimension here, 36 is our dimension here. What we're trying to calculate is going to be the diagonal. So we're trying to calculate the C. So this is my A, this is my B, and measurements of TVs is measured. This wouldn't be a 36-inch TV. The measurement is based on the diagonal. So again, we're using the Pythagorean theorem. So we have 27 squared plus 36 squared equals C squared, okay? So 27 squared plus 36 squared, we get 2025. So 2025 is equal to c squared. Now the opposite of raising something to a power is to take the square root. So that now is going to give us c equals. So second square root 2025 gives us 45. So 45 is the length of the TV. The hypotenuse could be a 45-inch TV. And that, ladies and gentlemen, concludes section 2 and 3. We will work on section 4 in our next class period.